This video is solving a system of equations by substitution, part 2. When you have a system of equations where both of the equations are in slope-intercept form, the easiest way to solve these is by substitution. You have y equals 4x minus 22 and y equals negative 5x plus 14. When you have both equations in slope-intercept form, you will take and set both equations equal to one another. Then you will solve the equations. Subtract 4x from both sides. So that gives you negative 9x plus 14 equals negative 22. We will subtract 14 from both sides. That gives you negative 9x equals negative 36. We'll divide both sides by negative 9. So x equals 4. Now that we know what x equals, we can turn around and substitute 4 in for either this x, for this x or either that x. Doesn't really matter. So let's take the top one. Y equals negative 5 times 4 plus 14. So y equals negative 20 plus 14. We change colors. So y equals negative 6. So our answer is 4 comma negative 6. That is the solution for this particular system. Let's look at another problem. Again, this is a system of equations that we're going to solve by substitution. Both equations are in slope-intercept form. So therefore, we will take both equations and set them equal to one another. So in doing so, we'll have 3x minus 13 equals negative 6x plus 14. So, excuse me, we're going to add 6x to both sides. So that's 9x minus 13 equals 14. We're going to add 13 to both sides. So 9x equals 27. We're going to divide both sides by 9. So x equals 3. Now that we know what x is, we can substitute x back in for this x in this equation or in the top one. Doesn't really matter. I'm going to plug it into the first one. Y equals 3 times 3 minus 13. So y equals 9 minus 13. So y equals negative 4. So our answer is 3 comma negative 4. Let's do one more. Well, that is it. So this video explains how to solve a system of equations using only two equations that are in slope-intercept form. So we will, since both of them are equal to y, we will turn and put both equations equal to each other and then solve. Note that we've got an ordered pair, which means that these two lines intersect. This concludes the second part of solving systems by substitution.